Well, today we are going in this video work with this data set. In this data set, I have determined the ethanol content in 8 different distillated beverages. The beverages as in here, I just give numbers as letters for each beverage. These beverages were cachaça and vodka. Cachaça was also known as the Brazilian vodka. So I have determined the ethanol content in this beverage using the phenolphthalein method. The phenolphthalein method is based in the shading of the pink color of phenolphthalein. For example, if I have alkaline solution with phenolphthalein, it will get pink. If I add to the solution ethanol, the addition of ethanol will make the pink color fade. So I have determined the ethanol content in each beverage using these 3 different equations. The description of these equations were provided in the description of this video, but what we have in here, we have 3 groups, but these 3 groups were dependent. We have 3 dependent groups that I want to compare. How could I compare dependent variables? If you observe the last videos of this playlist, I already have compared more than 2 groups. I compare more than 2 groups using ANOVA and ANOVA, but I have independent variables. In this case study, I have dependent variables. How could I compare dependent variables? I can do this using the commander. First, I will load my data, import from Microsoft Excel file. I must assign this line because I have names for each sample. In another examples that I have worked in this playlist, my samples don't have names. In this case of study, my samples have names. Let me go into OK. I will load this data set. I will load this data set in my commander. Now the data set was loaded. And I can compare this data set using statistics means one factor repeated measure ANOVA or one away repeated measure ANOVA. In here, I'm going to select the factors. That was equation 1, equation 2, and equation 3. And the name for the within subject factors were beverages. I'm going to OK. Oh, sorry, let's do again. Statistics, MENS. Options. I am doing a univariated analysis. I have 4 options in here: multivariate test statistics. I have Pillai, Wilks, Hotelli, and Roy. Normally, the most common option is the Pillai, and I can show this kind of graphics in here. Plot response means by factor, and print means and standard deviations by factors. Let me go into OK. I have the equation 1, 2, and 3. And I have the results obtained with these 3 equations in here. I have the results obtained with these 3 equations. And in Commander, I have the results. I have the results in here. The null hypothesis was not rejected. The null hypothesis was confirmed by the repeated measure ANOVA, assuming sphericity. The standard deviations of my data set, the sphericity of my data set was not confirmed. And doing the repeated measure ANOVA using the correction, since my data don't have sphericity, I already have the null hypothesis confirmed. So I can say in this example that the ethanol content measured with these three equations were equivalent. For example, if I am analyzing three different methods, but I have analyzed independent samples, my variables were not dependent. If my variables were not dependent, I use simple one-way ANOVA. But for example, I have one sample, and I determined its ethanol content using three different methods: gas chromatography, spectroscopy, and density. I can compare these dependent variables using the repeated measure ANOVA. That is this option in Commander. It is a very useful. It's a very useful function when you have to compare more than two groups and these groups were dependent.